all, welcome to ESE Electronics. Today's class we are going to see some problems from the Zener diode session, because Zener diode is an important area of the electronics. You can face a lot of questions from the Zener diode areas. In this video we are going to see some of the important questions from the Zener diode area. Okay, so this is useful for your ISRO scientist or technical assistant exam and also for your GATE exams. Okay, so what is the symbol of a Zener diode? This is a symbol of a Zener diode. Normally we will represent diode using an anode and cathode, but here if you see, the cathode of the Zener diode is little different. Now, what is the difference between normal diode and the Zener diode? We know that normal diodes, we call them as unidirectional switches, right? That is, they only conduct in one direction, they block the current in the reverse direction. So that is why they are being used in rectifiers and all other circuits. But in case of a Zener diode, the Zener diode conducts in the reverse bias condition also. That is, in both directions they will allow the current to pass. So that is the important property of a Zener diode. Now, if you see the normal diodes, they also exhibit the flow of current in the reverse bias condition in some cases. But what will happen if the voltage is increased? It will cause the breakdown of the normal diodes. That is, in the reverse bias condition, we cannot really predict the behavior of a normal diode. But for the case of a Zener diode, we can predict how the diode will work. That is, according to the voltage, only the diode will conduct in the reverse bias condition. So, ideally, we can say that the Zener diode is a diode which conducts in both directions. That is, it conducts also in the reverse direction or in the reverse bias condition. But the ideal diodes or the normal diodes, they don't conduct properly or they do not conduct current in the reverse bias condition or reverse condition. That can lead to avalanche breakdown and all other problems. Okay, so that is the main difference between a Zener diode and an ideal diode. Now, this is the basic things about Zener diode. Now, let us see some questions about the Zener diode session. Okay, so this is a simple circuit given, and in this question, you need to find the value of VL, IZ, VR and PZ. That is the first part of the question. In the second part of the question, here there is a load resistor given. You need to fix the value of load resistor as 3 kilo ohm. Here again you have to find these values. So first let us see what is the circuit. In the circuit you have a voltage source here. You have a resistor which is having 1 kilo ohm value, and also you have a Zener diode. The Zener diode's threshold voltage or the voltage needed to turn on this diode is 10 volt. Also, this load resistor is connected in parallel to the Zener diode and the value is 1.2 kilo ohms, and BL is a voltage coming across the load resistor. Now we need to find the value of VL, IZ, VR and PZ. First, let us try to find the voltage coming across this load resistor. We know that when this load resistor is connected in parallel along the Zener diode, means the voltage coming across this diode will be equal. We know that in parallel connection, what is the case? Voltage is same, right? So here whatever voltage is coming, that voltage will be also seen across this resistor. So how much voltage is being dropped across this Zener diode? Let us see. Don't get confused with VZ. It is the threshold voltage. Means that much voltage is needed to turn on the diode. That is not the voltage coming across the diode. It is just given that VZ is the threshold voltage of this Zener diode. Now, we need to find the value of V Zener or the voltage coming across the Zener, and how much voltage is coming across the Zener we need to find. The total voltage of the voltage source is 16 volt, out of which some amount will be coming here and some amount will be coming here. That is across the series resistor and the Zener, right? So, how to find that value? We can apply the voltage division rule, right? So, V Zener is equal to total voltage is 16, right? 16 into there are two resistors, load resistor and the series resistor. So into 1.2 by 1 plus 1.2. Okay, so this is a voltage division, and 16 into how much it will be? 1.2 by 1 plus 1.2 means 2.2. You can write this as 16 into 12 by 22. Okay, and if you solve it, you will get the value as 8.73 volt. So this much of voltage is coming across the Zener. Okay, now out of the 16 volt, 8.73 is coming across the Zener. One thing is clear, the Zener will be in which condition? It will not conduct, because the threshold voltage or the voltage needed to turn on this diode is 10 volt. But the voltage coming across this diode is only 8.73 volt. So this diode is not in conducting mode, and hence it will act like a open circuit. So in the basics of diode video also I have explained, when a diode is conducting means you can represent that conducting diode as a voltage cell or a source. But when it is not conducting, it acts like a open circuit, means there is no conduction there. So it acts like a open circuit. Now from these all things, we can infer 2-3 things. That is, first one is the current is 0. When a circuit is open, the current flowing through it will be 0. So IZ is equal to 0. Okay, that is the first thing. Now, here how much voltage is coming? 8.73 voltage is coming. 8.73 volt is coming across this diode, we have found out. So we have talked in the beginning that whatever voltage is coming here is the voltage across the load resistor also. So 8.73 volt is equal to V Zener is equal to V load, or the load voltage is equal to 8.73 volt. Okay, so we have obtained the value of the VL also. VL means the voltage across the load resistor. Fine. So we have obtained the value of IZ as 0, VL as 8.73. Now what will be the value of PZ? PZ means the power dissipation across the diode, Zener diode, or the power dissipated by the Zener diode is PZ. PZ is calculated using IZ into VZ. Right? Power is equal to current into voltage. Here current value is 0. So power value will be equal to 0. Okay. So PZ is 0 watt. So we have obtained this also. Now from this question we obtained the value of VL as 8.73, IZ is 0, PZ is 0. Now we need to find the value of VR. Okay. So as I told, the total voltage of the voltage source is 16 volt. Out of this 16, some amount is given to the Zener. V Zener. That is equal to VL also. And the rest will be coming across the resistor, which is equal to VR. Okay. So what will be the value of VR? So VI, you can write it as VR plus VL or V Zener. So from this we have VI, we have VL or V Zener. What will be the value of VR? VR is equal to VI minus VL. That is 16 minus 8.73, which is equal to 7.27. The voltage coming across this resistor. That is, out of this 16, 8.73 is coming across this, which is same as this because they are in parallel. Rest voltage is coming across this series resistor. Okay, so this is a very simple question. So we need to find that whether this diode is conducting or not conducting. For that case, we have given the value of VZ or the threshold voltage of the Zener. But when we found out the value of the voltage coming across the Zener, it is less than the threshold. So the diode is not conducting. Okay, so what will happen? It acts as an open circuit. So no current and no power coming across this. And from this 8.73, since total is 16, 8.73 is coming across this, so the remaining will be coming across the resistor. Okay, so the first part of the question we have completed. Now in the second part, they have given the load resistor value to take is 3 kilo ohms. Okay, so let us try to do it. Now I am going to draw back the diode here. The VZ is again 10 volt. Now the change is for the load resistor value, which is 3 kilo ohms. Okay. Now we have changed the value from 1.2 to 3 kilo ohms. So let us now find what is the value of voltage coming across the Zener when the load resistor we have changed to 3 kilo ohms. So V Zener is equal to how much? Out of this 16, that is, we are going to apply the voltage division rule. 16 into 3 by 3 plus 1, that is 16 into 3 by 4. 4 4s are 16. So 4 into 3 is equal to 12 volt is coming across the Zener. Okay, earlier it was only 8.73 volt. Now it is 12 volt. So if it is greater than 10 volt means the diode is conducting. Now the diode is in conducting mode. Okay, so there is a 12 volt coming across the diode. Now the diode is turned on. Okay, so the diode is turned on and the voltage drop across the diode will be how much? Will be equal to its threshold voltage. So this thing you should know. Earlier only 8.73 volt was coming across the diode and it was acting like an open circuit. So there was a voltage drop of 8.73 in this area, that is in the open circuit, which was equal to the load voltage. Okay, but since now the diode is turned on and the voltage drop here is equal to its threshold voltage, which is equal to 10 volt. Okay, so what will be the value of the load voltage or VL? VL will be now equal to VZ or the threshold voltage, which is equal to 10 volt. Okay, so don't get confused. Earlier, since it was an open circuit, here whatever voltage was coming was here because the diode was not conducting. Okay, so when the diode is conducting means the voltage drop here is only 10 volt. So that will be the voltage coming across the same. The voltage will be coming here also, which is VL. So VL will be equal to VZ equal to 10 volt. So now we have VL value equal to 10 volt. What will be the value of IL? IL means the current through the load resistor. IL will be equal to VL by RL. That is, VL is 10 volt by RL is 3 kilo ohms, which is equal to 3.33 milliampere. Will be the value of the load current. Okay. Now, we have obtained that the value of VL is equal to 10 volt. What will be the value of VR? VR is equal to VI minus VL. That is, out of this 16, 10 volt is coming here. And same as here, drop, there is a 10 volt drop. There is a 10 volt coming here. So, the rest voltage will be across the series resistor. Same as the previous case. So 16 minus 10, which is equal to 6 volt, will be coming across this resistor, which is the value of VR is equal to 6 volt. Now what is the value of this this current flowing through this resistor? That is IR. What is IR? IR is equal to VR by the value of R. Okay, so VR means 6 volt. So 6 by 1K. So 6 milliampere is the value of current coming across this resistor. Now we have, what all things we have? We have VL is equal to 10 volt. We have VR is equal to 6 volt. Also, we have the value of currents. That is IL is equal to, I'll write it here. IL is equal to 3.33 milliampere and IR is equal to how much? 6 milliampere. This much we have. Also, if the current here is IR is coming this way, this current according to the Kirchhoff current law is getting splitted here and here, right? So, we can write the current equation IR is equal to IZ, that is the current through the Zener plus current through the load. Simply we have applied Kirchhoff current law in the node. So IR is 6 milliampere. 6 milliampere is equal to IZ plus IL value is 3.33 milliampere. So what will be the value of IZ? IZ is equal to 6 minus 3.33 will be the value of your IZ. Value of IZ is 2.67 milliampere will be the value of your IZ or the Zener current. Okay, now we have IZ is equal to 2.67 milliampere. Now we need to find the value of PZ also, that is the power getting dissipated across the Zener diode, right? So what is the value of the power? Power PZ is equal to VZ into IZ, right? So VZ is 10. 10 into IZ is 2.67. That is 26.7 milliwatt will be the power dissipated across the Zener diode. So in the earlier question, we don't have to calculate all these things because it was not conducting mode. So when the diode is conducting, the voltage drop across the diode will be equal to its threshold voltage. That is an important concept for the second part of the question. In the first part, since the diode was not conducting, it was just acting like an open circuit. Though this thing also you should know. And we had to calculate VL, IR. Okay, the earlier case we have not calculated IR. We have calculated VL, IZ, VR and PZ. So for this case, IZ and PZ was 0. Since the diode is not conducting, there is no power, there is no current. But in the second case, the diode is conducting, the voltage drop is equal to the threshold voltage and we have to calculate all the other parameters. Okay, I hope that the concept is clear now. So let us see another question. For the Zener diode shown in figure, Zener voltage is 7 volt. Zener voltage is 7 volt means the threshold voltage is given. The knee current is negligible. Now what is knee current? Knee current is the minimum amount of current needed to make the diode conduct in reverse bias condition. That is minimum current required in the reverse bias condition is called knee current. Is negligible. The Zener resistance is 10 ohm. If the input varies from 10 to 16 volt, that is VI varies from 10 to 16 volt, output voltage range is dash. That is what will be the range of your output voltage if the input is varied from 10 to 16 volt. Okay, so there will be a variation in the output voltage also, right? According to the input applied, there will be variation in the output voltage also. One thing we can infer from this statements or this question is that since the Zener voltage is 7 volt, the Zener voltage or VZ is equal to 7 volt. The VI varies from how much? From 10 to 16. So anyway, the Zener diode will be in which mode? In the conducting mode, right? Because 10 volt to 16 is always greater than 7 volt. So the Zener diode is in conducting mode. That is inferred. Okay. So when this diode is conducting, we can replace this diode as a voltage connected with series resistor, because in the question if you see, it is given that the Zener resistance is 10 ohm. That is the internal resistance of the Zener is 10 ohm and the threshold voltage is 7 volt. Means we can replace this Zener diode in conducting mode as a series resistor followed by a voltage. We can replace this diagram with the series resistance and the voltage source. In the earlier diode basic video also I have explained when the diode is conducting, we can replace it as a voltage cell or a source, because that much of voltage drop is coming there when it is conducting. We can assume that voltage value will be equal to its threshold voltage. That is the case when the diode is conducting, and when the diode is not conducting means it acts as an open circuit. Here, since in the question they have given the internal resistance and also the threshold voltage, we can replace that conducting diode as a series resistor connected with a voltage cell. The value of the series resistor will be equal to its internal resistance 10 ohm, and here the voltage cell or this voltage is equal to the threshold voltage 7 volt. I hope this is clear. When the diode is normally conducting, we draw a voltage cell. But here, since the resistance is also given, we can draw it in series with the internal resistance. Simple, right? Now, we need to find what? We need to find the range of this V out when Vi is varied from 10 to 16 volt. First, let us see what is the voltage coming across V out. In the previous question also, I told you when this voltage we are going to consider or calculate, it is coming in parallel with this connection. Whether it is a resistance or whether it is a diode, it is coming in parallel with this connection, right? So, V out will be equal to this much. Whatever voltage is coming across these two terminals will be equal to this voltage, right? Since it is a parallel connection. So, V out will be equal to 7 volt plus 10, that is this voltage plus the voltage drop across this 10 ohm. I'll draw it here for you. See, we are going to calculate this voltage, V out. Okay, there is a resistor here, there is a voltage source here, there is a 7 volt. So, this voltage is ideally the voltage across these two terminals since they are in parallel. So, we have to calculate the voltage drop across this resistance, and also we have to sum that voltage drop plus this 7 volt to get our V out. So, we can write V out's equation as V out equal to 7 volt plus 10 ohm. The voltage drop across this 10 ohm will be equal to 10 into the current in this circuit. Okay, so whatever current is passing through this circuit will also flow through this 10 ohm. So, the voltage drop across 10 ohm is equal to 10 into the current IS. Right, that is the current in the circuit. Now, this current in the circuit can vary according to the voltage applied. We are saying that the voltage is first applied as 10 volt, then it is changed as 16 volt. So, the current in the circuit or the IS will also vary according to this current, right? So, we will have two currents, IS1 and IS2. IS1 will be the current produced when 10 volt is applied as input. Then IS2 will be produced when 16 volt is applied as input. So, we have to find IS1 and IS2, and we have to find the V out for both the cases. So, then we will get the range of V out. Okay, now I am going to first find the value of IS1. I need to find IS1 or the current in the circuit when Vi is equal to 10 volt. So, I am going to consider now only Vi as 10 volt. So, I am going to apply a 10 volt here. So, this 10 volt is being applied here. What will be the current in the circuit? This 10 volt, if you consider this loop, there is a 10 volt here, there is a 7 volt here. So, 10 minus 7 by, there are two resistors connected in which connection? Series connection. So, total resistance is 200 plus 10. So, 200 plus 10, which is equal to 10 minus 7 is 3. 3 by 210 ampere is the value of your IS1, which is the current in the circuit when Vi is 10 volt. Now, apply this to your V out equation. V out is equal to, for 10 volt, so I am going to call it as V out 1. V out 1 is equal to 7 plus 10 into 3 by 210. 3 by 21 you will get 21. And if you calculate this, you will get the value as 7.14 volt. Will be your output voltage when input voltage is 10 volt. Similarly, you have to calculate V out 2 when Vi is equal to 16 volt. Okay, so the first range is 7.14. Okay, there are two 7.14, so you cannot really answer this question with V out 1. We have to calculate V out 2 also. For that, I am going to first calculate IS2, or the current in this loop due to, that is when VI is applied as 16 volt. So IS2 is equal to, now I am going to apply how much? 16. 16 minus 7 by total resistance is series connection. So 200 plus 10 again. So 16 minus 7 is 9 by 210. Apply this current in the V out equation. So how will you get? V out 2 is equal to 7 volt plus 10 into 9 by 210, which is equal to 9 by 21. So if you solve it, you will get it as 7.43 volt will be your answer for V out. So the voltage ranges from 7.14 to 7.43 volt. This is your range of output voltage. So the correct option here is option C, which is 7.14 to 7.43 volt is the range of your output voltage. I hope the concept of this question is clear. So in majority of the cases, when output voltage is coming, being asked to calculate, you have to find the voltage drop in this terminal, that is across a diode. So when the diode is not conducting, it is an open circuit. So you have to find how much voltage is coming. When the diode is conducting, it acts as a voltage cell. So you have to think about the threshold voltage. And if the series resistance is given, you have to consider that also. Here, so the voltage ranges from 7.14 to 7.43, and the correct answer is option C. In the circuit shown below, the need current of the Zener is 10 milliampere, means minimum 10 milliampere is needed to operate the diode in reverse bias condition. That is 10 milliampere is minimum required in reverse bias condition. To maintain 5 volt across RL, find the minimum value of RL. So we need to maintain a 5 volt across RL. So for that, what will be the value, minimum value of RL? Okay, so if the value of voltage coming across this resistor is 5 volt, that is we need to maintain a 5 volt, means this diode will be in conducting mode, right? So the voltage drop across this resistor is also 5 volt, means this diode is in conducting mode, and the voltage drop here is 5 volt. Okay, so another thing to note is that since there is a resistor connected here, there will be some voltage drop across this resistor, which is 100 ohm, and there will be some current flowing through this resistor, and the current flowing through this resistor is getting splitted across the Zener and the load. So if this value of current is IR, the IR is getting splitted as IZ plus IL, right? So IR value is fixed, right? Since it is a current flowing through a resistor, the current value IR is fixed. Now IZ is the current flowing through Zener, and we need minimum how much current is needed is 10 milliampere. That is minimum 10 milliampere is needed to operate it in reverse bias condition. That is a knee current is 10 milliampere. So IZ will take as 10 milliampere. Now what will be IL? IL should be maximum, because we need to find the minimum value of resistor. Okay. Anyway, we'll talk about it later. First, what is the voltage drop coming across this resistor? We know total voltage is 10 volt. Out of which 5 volt is coming across the Zener diode, and the rest or the remaining voltage is coming across the resistor. Since all these previous problems also we have done like this. Out of the total voltage, some voltage is coming across this Zener, and the remaining is coming across a series resistor. So there is a total 10 minus 5 is coming across the Zener, and that will be equal to your this voltage. Let it be VR. VR is equal to 10 minus 5 equal to 5 volt. Okay, that is the resistor, that is the voltage across this series resistor. Now, what is the value of current flowing through this resistor? So, what is the current? IR is equal to, we have called it as IR, right? IR is equal to VR by, that is a voltage across the resistor, by the resistor value, which is 100. Right? So, IR will be equal to how much? VR is 5. 5 by 100. That is 50 milliampere will be the current through that series resistor. Now we have obtained the value of the resistor current, that is the current flowing through this this resistor, series resistor, as 50 milliampere. Again, we were talking about the current equation, right? What was the current equation? IR is equal to, I'll write it once again here. The current IR, which is flowing through this resistor, is getting splitted as IZ plus IL. I've talked that IZ will be minimum, how much is required? 10 milliampere is required. Otherwise, the diode won't operate properly. So, IR is equal to 10 plus IL. Again, IR value we have obtained as 50 milliampere. So, 50 milliampere is equal to 10 milliampere plus IL maximum we are talking about, because we need to find the minimum resistor. If resistor is minimum, current will be maximum, because they follow an inverse proportionality. Anyway, so the IL will be obtained as 50 minus 10, which is equal to 40 milliampere will be the value of IL or IL maximum. Okay, now we have obtained the value of current through this load. So we have obtained the value of IL as 40 milliampere. We know we need to maintain how much voltage? VL we need to maintain as 5 volt. So what will be the value of RL? Simple, right? RL equal to VL by IL. That is how we can calculate the minimum value of resistance for this load resistance to maintain a 5 volt across it. So I'm going to calculate it. VL is 5. 5 by 40 milliampere. So into 10 raised to 3. Okay. So 5 by 4 into 10 square or 100. 5 by 4 means 1.25, right? 1.25 into 100, that is equal to 125 ohm is the value of minimum value of resistance to maintain a 5 volt. I hope this is clear. So in this question, they are asking how much is the value of the load resistance. There is a minimum value of load resistance we have to keep to maintain a 5 volt across the load. Okay, so for that case, we have to use the current equation here. We know that this current, that is the current flowing through this resistance, is getting splitted across the Zener and the load. So we have to maintain a minimum of 10 milliampere. And we have to make this current as maximum because we need to find the minimum resistance value, right? So we are keeping this as 10 milliampere minimum. So the current is 40 milliampere through the load resistance. Now we have 5 volt and also the value of current. So we can find the value of the load resistance, and it is equal to 125 ohm is the value of the load resistance obtained. I hope this is clear. So we have discussed a couple of problems from the Zener diode session. We have to keep this thing in mind that when the Zener diode is conducting, the drop across the Zener is equal to its threshold voltage. That is the minimum voltage required to conduct. Otherwise, it is acting as an open circuit. This is a main thing when you have to keep in mind when you are doing such problems. I hope this is clear. So these are the questions which I have included in this video. We'll be seeing in the next video with some more questions. If you want the part 2 of the Zener diode video, please do mention that in the comment section. We'll do more videos, that is more parts we'll do about the Zener session. And if you found this video useful, please do give it a thumbs up and also share this video with your friends. And if you want more videos, please do subscribe to the channel. Thank you.